Okay, so I've ran it for a full battery and everything seemed to work just fine. So I'm gonna, before I put the blades on, I'm gonna stow a few wires. So what I like to do with this wire set is I pull them tight and run them back and forth right over the top of the motor right here, and then I'll zip tie each end of this. And that's get these servo wires stowed. Then on the inboard side, I like to put one zip tie hooking my motor wires and keeping them in tight. And I put it, it's hard to see, but I put it through that rectangular hole, which on the opposite side is where the power wires go through. And then a pop triangular hole right in front of the motor pinion. If you're doing the scale kit, these wires kind of need to stay flat and close in. Okay, so those hold those wires in, and now I'll do the other side off the camera, but that's how I like to stow all my wires on the nacelle. Now the kit the kit comes with blades. And they're in match sets of 3, so you don't want to mix them up. You want to keep them in the set. We also come with the blade bolts. The rotors rotate such the blade rotates towards the wing. So I'll just set these 3 blades in here. Then I'll put on the nuts. Now you don't want to tighten these blades up super tight. You want them to be able to get flung out straight when you spool them up. It's hard for me to show you. I don't like them to get real loose because then they can flop around, but it's hard to say exactly how tight, but just light finger pressure here can move them around is the way I like to set them up. So I like to identify the blades, so after I track them and everything, I can put the blades back on and take them off and put them on and not get them mixed up. So I'll put a drop of red paint on, this is where I like to do it, on one blade on each side. Then I'll do a drop of white. Now what I do is red, and then the next blade will be white. In the direction of rotation, right? And then the next one will be blue, red, white, blue, in the direction of rotation. And this gets you two things. One, it gets the same blade on the same grip, and all prevents you from mixing up right and left hand blade sets. Okay, so now we can continue on with step 10 in section E. And I'll turn on my transmitter. Let's just do it right. I'll turn my gyro to hold mode, heading hold mode. I'll apply power to the ship. I'll check that my gyro's initiated. Then I'll turn them back to rate mode. So the first thing I like to do is check that at the quarter stick position, and I can go back into my throttle curve. It's, for me, is the easiest place to kind of get exactly, or pretty close where quarter stick is. I want to see if my blades are at 0 degrees collective pitch. Make sure you get your gyro turned to rate mode, and if you put two blades, lean them back and parallel to one another on each side of each disc. If your blades are at 0 collective pitch, the tips will be at the same elevation. And this left side blade set looks perfect. My right blade, I got, you can see it over there, a little bit of offset there, about an inch. That's probably 2 turns. So I'll take my swash plate links, the 4 links go into my swash plate, and I've got too much collective pitch, so I'm going to drop each one of those down 2 turns each. Okay, now I want to make sure my collective pitch range is set up right, so I'm going to go full down on my collective pitch stick, and I'm going to see if I have 2 inches from tip to tip. I'm a little bit short. I'm a little bit short there. I'm going to go up full, and I want 6 inches here. Full 6 inches. I've got about exactly 6 inches here, maybe just a little bit, maybe a 1/4 inch more than 6. Now this should be about right if you set up your you set that plus or minus 4.5 millimeters, a total travel of swash plate travel. My other side looks good just looking at it. Now that I messed with it a little bit, this set of blades could come down 1 turn each. I think that's going to get it for me, so let me do that real quick. I'll pop off the 4 links off of the swash plate on this side and bring them down just one turn each. That's tight. If you got a tight ball link, if you just squeeze it, take a pair of pliers and squeeze it, you can really, you don't want to squeeze it so much that it gets sloppy, but you really want to be able to twist the ball link just by grabbing the black portion of it. I'm going to bring these each in one turn. Make sure that 4th link isn't at any preload. And now, yeah, now these seem much more balanced. I got about 2 inches when I'm at full negative pitch and 6 inches when I'm at full positive, so looks much better, much more balanced. So if you just can't get there and you need some more collective pitch, I like to do it in the configurator program where we adjusted that swash plate travel range. You can just add a little bit more travel or a little bit less, but it's important that you want a lot of collective pitch. That helps the pitch governor get fully engaged when it needs to, and keeps your climb rate brisk. And you need a lot of collective pitch when you're in airplane mode to keep the airplane moving. So that actually gets all of section E, and we can move on to actually trying to spin the thing up.